The lesson for today is on sequences. So we've been spending a lot of time with series, which is the sum of the terms of a sequence. So we're kind of taking a step back and just looking at the individual terms or the sequence. So what is a sequence? A sequence is a function whose domain are positive integers. That is 1, 2, 3, and so on. So we always start with plugging in 1 and getting out a value. So let's look at this sequence here. 1, 1/3, 1/5, 1/7. So hopefully you can see a pattern. We're going to write an expression for the nth term. Well, in all of these, we have a numerator of 1. The denominator are odd numbers. So we know we can get an even number with 2n. So if I want the odd numbers, that's going to be 2n minus 1 will give me the odd numbers. And you can always check by plugging in. If we plug in 1, we're going to have 1 over 2 minus 1, which is 1. We plug in 2, we're going to have 1 over 3, so we're good. We can use graphing calculators to graph sequences so we can see their behavior. So we're going to look at this sequence. N minus 1 over n. And we've got 0, 1/2, 2/3, 3/4, and so on. Because if we plug in 1, we get 0 over 1. We plug in 2, we get 1 over 2, and so on. So on your calculator, we want to be in parametric mode. So go down to function, and rather than function, we want parametric. There's different options here. There's thick. We want dot thick. Then when we go to y equals, we have our x1, y1, and you'll notice the dots are here. Now you could have also done this by just changing the line type. Okay. So my x is just going to be t, which we'll get from the variable button. The y is going to be, we'll do our fraction, t minus 1 over t. Now, how are we going to graph a sequence rather than just a line? We're going to go to Window. We're going to go from, in our t's, and this is on your notes here, we're going to start with 1. We're going to go to 10. And our step is going to be 1. Okay, so this will graph 1 point for every number between 1 and 10. Now, if we look at these numbers, a good window for my x's, we want to go from 0 to 11 because we're going to have 10 numbers. And then for my y's, I'm going to go from 0 to a maximum of 3 because we can kind of see that these numbers aren't going to get real big. Then when we graph, we get these distinct dots. Okay, these dots, and we can see just from the pattern of numbers, are approaching 1. Okay, so we say that this sequence converges. Now there's a difference between a sequence converging and a series converging. The sequence just means that the terms aren't getting any bigger. All right, consider this sequence. We're going to graph it. So in my calculator, I'm just going to change the second equation here into t over e to the t. And we'll graph it on the window we have, and if we need to adjust, we will. Okay, so the dots are going way down here. Okay, so you can transfer this to your notes or not, that's up to you. Does it appear that they converge? Well, let me change my window so I can see it a little bit better. Okay, these are going closer and closer to 0. So we will say this converges. Okay, and we're going to find the limit as n goes to infinity of n over e to the n. Well, this exponential is going to grow way faster than just n. So this goes to 0, which is what we saw graphically. So this converges. And our explanation can just be the limit as n goes to infinity exists. All right, we'll do this again. So I'm going to change my equation to, this is going to be the same as n to the 1 over n. So I'm going to make my new equation here t to the 1 over t. Let's graph it. Can't really see our point, so I'm going to go ahead and expand my window. To go up to 3. And there are my dots. So this one starts down here, goes up a little bit more, then starts going back down. So again, you can plot that on your notes. Does it appear to converge? Yes. Those values are approaching this line right here, which appears to be about 1. Analytically, this one's limit as n goes to infinity of n to the 1 over n. So anytime I have something like this, where I have a variable in the base and in the exponent, we're going to use logarithms to deal with that. So I have n to the 1 over n. So the natural log of y is going to equal 1 over n natural log of n. So I'm going to look at this limit. So we're going to look at the limit as n goes to infinity of ln n over n when I multiply that in. Okay, well that's going to go to infinity, and that's going to go to infinity, which means we can use L'Hopital's rule. So this is going to be 1 over n over 1. So that's just going to be the limit as 1 over n goes to infinity, which is 0. So the natural log of y goes to 0, which means y is going to go to e to the 0, which is 1. So this limit is 1, which we saw graphically. So does it converge? Yes, because there's a limit. Alright, so our next one, an equals -1 to the n plus 1 over 1 over n. Okay, so this is the alternating harmonic series. Let's go ahead and look at the terms. So we're going to have -1 to the t plus 1 times 1 over t. Now this is going to include negative values. So for my window, I'm going to go from t's we're going to leave alone, x we'll leave alone, but from -1 to 1 will be good. Okay, so what we have here, we've got our 1, down here at -1/2, 1/3, -1/4, and so on. So they're bouncing around, but does it appear to converge? Yeah. Okay, it's going to 0. So we've got the -1 to the n plus 1 times 1 over n. So this is just going to bounce between -1 and 1. But this is going to go to 0. So even though it's bouncing around closer and closer to 0. So this is 0. Does it converge? Yes, there's a limit. Then we have the good old-fashioned famous Fibonacci sequence where A1 and A2 are 1, and then the terms after that are the sum of the previous 2 terms. So the first 6 terms are 1, 1, add those, 2, add those, 3, add those, 5, add those, 8. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So we have 1, 1, 2, 3, 5, 8. So does this sequence converge? No, it does not. Now we're going to talk about monotone sequences. So a sequence that is either non-decreasing or non-increasing is called monotone, meaning it either is the same or increasing, or it's the same and decreasing. A sequence that is either increasing or decreasing always is called strictly monotone. So if it is always going up, there's no repeat, then it would be strictly monotone. Something like this would be called non-decreasing because it stays the same here and then increases. There's different tests that we can do to figure that out. We can look at the difference between successive terms. So if the difference of the nth plus 1 term is minus the nth term is greater than 0, it's increasing. If it's less than 0, it's always going to decrease. We can look at the ratio of terms. So if the ratio of an plus 1 over an is bigger than 1, it's increasing. If it's less than 1, it'll be decreasing. And then good old-fashioned derivatives, because if the derivative is always greater than 0, it's increasing. If it's always less than 0, it is decreasing. All right, so we have the series n over n plus 1. So the first 5 terms of this is going to be 1 over 2, 2 over 3, 3 over 4, 4 over 5, and 5 over 6. Try to draw this graph. 1, 2, 3, 4, 5. We're at 1/2, 2/3, 3/4, 4/5, 5/6. So if we look at it, it does converge, but is it increasing or decreasing? Well, that looks like increasing. Now we're going to do the 3 calculations to determine if it's increasing or decreasing. So an plus 1 minus an. So this is an, so an plus 1 is going to be n plus 1 over n plus 2 minus n over n plus 1. I'm going to need a common denominator, so I'm going to multiply this one by n plus 1 over n plus 1, and I'll multiply this by n plus 2 over n plus 2. So FOIL that, we're going to have n squared plus 2n plus 1 over n squared plus 3n plus 2 minus n squared plus 2n over n squared plus 3n plus 2. So when we take this and subtract this, n squared minus n squared, 2n minus a 2n, so we are left with 1 over n squared plus 3n plus 2, which will always be greater than 0, which means this is increasing. Now we'll do the ratio. So I'm going to take the nth plus 1 term over the nth term, so we'll have n squared plus 2n plus 1 over n squared plus 2n. Well, this is always going to be bigger than 1 because these are the same, and then this is 1 bigger than it. So if the ratio is bigger than 1, it increases. Now let's look at the derivative. Now I don't know why we got to replace it with x, but we'll go with it. So we're going to take this derivative using the quotient rule. So that's going to be the derivative of x times the bottom minus x plus 1 prime times x So the derivative of x is just 1, so we have x plus 1 minus, that's derivative is 1, so minus x. So x minus x goes away, so we have 1 over x plus 1 squared, which is always positive, sorry, greater than 0, always positive, so it is increasing. If the derivative is positive, we are increasing. Alright, so we've got this guy here. First 5 terms is going to be e over 2 factorial when we plug in 1, e squared over 3 factorial, e cubed over 4 factorial, e to the 4 over 5 factorial, and e to the 5 over 6 factorial. Okay, we can graph this on the calculator or by hand if you felt like it. So we have e to the t divided by, in parentheses, minus 1 plus 1 factorial, and you can find factorial in our good old function menu. It's number 9 there. Okay, let's go to a y minimum of 0 and a y max of 2. Okay, so it starts here and goes boom. Okay, so I'm going to go ahead and predict this is decreasing. And then we'll do the ratio technique. So when we have factorials and exponentials, we know things fall apart. So e to the n plus 1 over n plus 2 factorial over e to the n over n plus 1 factorial. So we're going to have e to the n times e over n plus 2 times n plus 1 factorial times n plus 1 factorial over e to the n. Apologies. So e to the n, n plus 1 factorial, n plus 1 factorial. So we get e over n plus 2. This is so e is about 2.718. So when we plug in 1, you're going to have 2.78 over 3. If you plug in 2, you're going to have 4. So the numerator is smaller than the denominator, which means this is less than 1, which means this is decreasing. N has to be bigger than 1. The upper bound, the biggest the term was, and we can get this from the graph, was that first one with e over 2. And our lower bound is 0. It's never going to get less than 0. Okay, so does the sequence converge? Yes, because it has an upper limit and a lower limit. Or you could just say it has a limit. Last question, and this is more traditionally how you're going to see it on the AP exam, would be which of the following sequences converge? Not series, sequence. So you're looking at what are these limits? So this one's going to go to 5 halves. So it has a limit, which means it converges. E to the n over the n is going to go to infinity, so that will not. This one is going to go to 1. So it converges. So 1 and 3 converge.